Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. And yes, I Rakesh Sir welcome you once again to this digital electronics concept classes. And yes, we are, as you know, from the past 2-3 days, we have started to learn the concepts in the latches and flip flop, because one of the most important and crucial chapter for digital electronics is sequential circuits. And to be really comfortable with sequential circuits, we know we need to have the good understanding of flip flops and latches. Yes, so yesterday we came up with SR latch, and today we are going to move towards the D latch, the Jk latch, the T latch. Okay, so today we basically complete different variety of latches, but as I told you, we are into latches right now. We are discussing latches right now, and moving forward we need to go into flip-flops. That will be starting from tomorrow, but the basic building block is latches. And yesterday what we saw the unclogged latch SR latch and the clogged SR latch. Both the cases we saw yesterday, right? And now let's move forward discussing other parameters. Good evening all. Good evening. Keep joining the sessions and keep sharing the session with your friends. Yes, let everybody join the session quickly. Yes, guys. Okay. All right. Yes. Okay, so students joining, will keep joining slowly. Yes, Navneet, I'll do share it up. I'll share it up, the PPT for both the classes today and yesterday also. So master your concepts in latches and flip flop. Let's get started. In case if somebody new to my session, this is a brief intro about myself. This is your mentor and educator Rakesh. I have secured All India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, Bangalore, and I have trained more than 50,000 students in my more than 11 years of teaching experience. I majorly deal with the subject of control system, digital electronics, electromagnetic theory, and signal and system. In the general area, I also deal with the maths and aptitude, guys. Yes. Good evening all. Okay. So Hall of Fame, yes, the BYJU'S Exam Prep students really outshined in the GATE 2022 examination. As you are able to see, All India rank 1, 2, 3 and many aspirants secure All India rank below 100. Yes guys, and if you are willing to prepare for GATE 23, GATE 24, and in case you need financial assistance from BYJU'S Exam Prep, yes, prove yourself. BYJU'S Exam Prep brings you a scholarship test on this Sunday, 1st of May at 11 AM. Yes, appear in the scholarship test and get scholarship up to 90% on the GATE preparation programs. Now guys, as we all know, we are all studying digitally these days, right? So current education, and many of the students have already adopted this online education. You guys are rigorously studying online, not only classes, even notes and PDFs also students are following online. So it's a total digital age, I can say, right? Which has multiple advantages. Sitting at a single place, you can get access to variety of content. It has multiple benefits. But what are some of the drawbacks that it can have on our health, and how to overcome it? We know that eventually, yes, online education is the era right now. We have to study digitally, but the stress and anxiety that the students are feeling in this digital age, how to feel and how to overcome that. So a very important session I'm going to bring you. Other than taking up this digital electronics class, I just randomly thought of this idea that many students are going through little bit maybe anxiety studying digital age. So let's try to find out the methods to overcome it, so that there is a balance. Your preparation should also go on the right track, and at the same time your health should also be on the very much right track. So join me live for this session. On this coming Saturday. What time, sir? On this Saturday, oh sorry, not the 8, it's the 10 PM. So join me live Saturday 10 p.m. Everybody can join me live for this session on this Saturday at 10 p.m. Okay. Yeah, a quick update that what are the classes we are having. Just to give you an update, you can take the screenshot of this. So yesterday we had SR Latch, today we are going to discuss D Latch, Jk Latch, T Latch, and then we have race around condition, master slave flip flop tomorrow, and etc etc. So this timings and class schedule, timing is fixed daily at 8 p.m. We are coming live to learn the concept of latches and flip flops. Okay. Right, now I gave you an assignment yesterday. Let's get started with this. Okay, let us get started with this. A simple assignment I had given you. Okay, let us start by discussion of this particular assignment. The following binary values were applied to the NOR gate latch, the basic SR latch that we discussed yesterday. The following binary values were applied to the NOR gate latch as given below. Okay, S equal to 1, R equal to 0, S equal to 1, R equal to 1, and S equal to 0, R equal to 0. Determine the corresponding sequence obtained at P and Q. Right, determine the corresponding sequence obtained at P and Q. Okay, yeah, I think it's not mentioned here. This is what is P and Q, and this is what is S and R. Okay, so this is what is the assignment that I have given you yesterday, and let's start discussing it. Now we all know that, everybody, let's come to the discussion. S equal to 1, R equal to 0 corresponds to the set combination. Whenever S is equal to 1, we know that the device will be set. That means the Q. Now, if you remember the yesterday's diagram, if you have followed the yesterday's class, because I told you all these 6 classes mostly will go into the continuity. So here we were actually calling it as Q, and here we were calling it as Q bar. So device being set means Q equal to 1. Q here is just represented by the letter P. I will tell you the reason also why I have named the letters as P and Q. Because we know that when both the inputs to SR latch is 1, the latch goes into invalid state, and Q and Q bar were equal. Why we call the invalid state as invalid? What is the problem? That's what I'm trying to explain you. As I told you, I will explain you actually what is the invalid state. So the device should be set, and set means the P output should become 1 and the Q output should become 0. This will become 1 and the another one will become 0. Right? So this is very much clear why it is so. Even if you want, we can do the analysis once again. Even if you want, we can do the analysis once again. It will take hardly a few seconds. Right, because whenever S is equal to 1, whenever the input to any NOR gate is 1, even if a single input is 1, the output becomes 0. So this output is immediately 0. Then this runs through to the second NOR gate. R ko 0 liya hai, S equal to 1, R equal to 0. So now if you look into the NOR gate number 1, both the inputs are 0, and if both the inputs of NOR gate are 0, its output will be 1. It is very simple. Right, it is very simple. Yes, Ishan, why it is unstable? That is what actually we are trying to discuss now. Okay, so this is what it is. The P will become 1 and the Q will become 0. That is what I have directly written, because yesterday we discussed that. Now S equal to 1, R equal to 1. We know that this is an invalid state. This corresponds to invalid state. So what happens now when both the inputs are equal to 1? So now I make the R is equal to 1. Okay, now I am going to make the R equal to 1. Now because the S is also 1, R is also 1, that means look at the NOR gate number 1. Any input high, output becomes 0. Look at the NOR gate number 2. Any input high, the output becomes 0. Right, that means whenever S is equal to 1 and R equal to 1, what happens? P becomes equal to 1, P becomes equal to 0. At the same time, Q also becomes equal to the 0. P and Q are both 0. Is this the actual problem? No. Yeah, we know that every latch should have 2 outputs and they should be complement of each other. Okay, they are not complement of each other, but is this the real problem? No, the real problem is something else. Now we know that this was named as invalid. This was named as invalid state. So we have the device now entered into the invalid state. What is the real problem? Now the real problem, everybody, now I am trying to apply S equal to 0, R equal to 0. Okay, which represents same state combination. Now I want to apply S is equal to 0, R is equal to 0. What will happen? what will happen? Everybody now try to understand what will happen. What will happen? So let us just refresh these combinations here. Very important concept coming up for you. So what it did earlier, S and R were both 1, so both the outputs became 0. Both the output became 0. Okay, now S is equal to 0, R is also equal to 0. Now see, this is 0, right? This is 0, it comes here. Assuming both the NOR gates have 0 delay, both the NOR gates have equal delay मान लेते, let's not say 0, right? So when I apply S is equal to 0, R is equal to 0, right? There will be 3 different types of discussion that I can have. Okay, number 1, let's keep the discussion simple. Let's assume both the NOR gates have equal delay. Now if both the NOR gates have equal delay, what will happen? Here also you get 0. Now the input to both the NOR gates is 0, and hence this output will become 1. Now because this output will become 1, it directly goes here. It directly goes to the NOR gate number 1, and any input to the NOR gate is 1, its output becomes 0. Its output becomes 0. But ये तो तब की बात होगी. This will happen if the second NOR gate is faster, if this produces the faster output. But actually what I am trying to say, if both NOR gates have equal delay, या assume 0 delay in both the case, then the story will be just C. Now once again, S and R both applied were equal to the 1. S and R both applied were equal to 1, and hence both the outputs were 0. Now S is also 0, R is also 0, here also is 0 because the earlier output was 0. Now input to the NOR gate number 1, both input 0 0, so the output is 1. At the same time, input to the NOR gate number 2, both 0, so this also becomes 1. So now P and Q both becomes 1. Now P and Q both becomes 1, and as soon as Q becomes 1, this comes here. As soon as P becomes 1, this comes here. Now one of the input to NOR gate number 1, one of the input to the NOR gate number 2 is 1. Any input to NOR gate is high, guys. Any input to the NOR gate is high, its output will now become 0. Now again both the outputs are 0. So what is going to happen? If S equal to 0, R equal to 0, P becomes equal to Q becomes 0, right? Then automatically P becomes equal to Q, that is equal to 1. Oh, sorry, first both became 1. Now both again become 0. Now because both again become 0, same story will repeat here. Earlier you left at 0, now both will again become 1. Now both again becoming 1, after some time both will again become 0. What is happening to the device? I have assumed 0 delay, right? So what is happening if you want to look at the P waveform? What is happening to the P waveform? Let's pick up P waveform. It was 0, then it becomes 1. Automatically without even changing the input, it becomes 0, then it becomes 1, then it becomes 0, then it becomes 1. It never settles to a state. It never settles to any state, right? It simply fluctuates between 0 and 1. So what is the next state of the device? You really can't say, right? It could be 1, it could be 0, or it could be just fluctuating between 0 and 1. Right? So what happens? This is one of the case. Okay, now even you can take multiple cases, that much I'm not going right now, but even you can take multiple cases. Suppose both the NOR gates have propagation delay but which are unequal. Second NOR gate faster, first NOR gate faster. If you take those cases, now output will be something else. The moral of the story is that whenever a device goes to invalid state, its next state is indeterminate. And hence that is why I was telling since yesterday that a user must take care. A user has to externally take care not to apply the SR inputs as high, both high. Both S and R equal to 1 should not be applied high at the same time, right? Should not be applied high at the same time. That is what is the analysis. Okay? That is what is the simple analysis, right? Yeah, Abhiram, please come up. Okay, now This is the clogged SR latch, already we discussed yesterday. Okay, this is what is just a review diagram that I am leaving in front of you. This is discussed in the last class. We have also discussed in the last class why we need the door, why we need the clocking. This is what is the clock pulse. We are right now talking about what? We are right now talking about level triggered devices. Later on, we'll also go towards the edge triggered devices. We will also go towards the edge triggered devices. Just a second. My screen is off. Just a second. We'll also go towards the edge triggered devices. Right? Okay. Chalo, let's keep moving ahead. Now, this is just a review of the last class. Now, intent is to go towards Jk Latch, D Latch and T Latch. Let me first cover up D Latch and then we go to the Jk Latch. When we go to the Jk Latch, the problem of SR latch will be eliminated. The problem of SR latch will be eliminated. Right? So, I will just write down a small point. When both S and R equal to 1, when both S and R equal to 1 at the same time, the next state of the latch is what? Is either fluctuating, I can call it as oscillatory, it just keeps on fluctuates, or it may be indeterminate if we consider unequal delays in the NOR gates, or is indeterminate. That is the actual problem of invalid state, right? That is why, hence, a user must take care not to apply both S and R equal to 1 simultaneously. दोनों को एक साथ अप्लाई नहीं करें. Right? This problem can be resolved. Sir, what is the solution? Does it have any solution? This problem can be resolved using Jk Latch. Okay, so once we go to the Jk Latch, we will talk about the solution of this. Right? Okay. First, let us go to the clogged D Latch. Now, this is a SR latch copied once again. You will say, sir, that is the same thing we studied yesterday. But yeah, I have copied this as I told you. Once you are clear with the SR latch. Yesterday also we started with the unclogged SR latch first of all. This is what was the unclogged SR latch, and then we went on to clocking. Why we went on to clocking? What is the problem with unclogged circuit? What is the problem with asynchronous circuit? Everything I explained you. Then we went on clocking. What type of clocking? Level triggered clock right now. Okay. Now the clogged SR latch was completed. This is not the D latch, but a small modification here will make it into a D latch. What is that? So this was actually equal to S and this was equal to R. Right, what I am going to do, let me call the S input as D input now. I'll just change the name. Acha, can anybody say like S and R is set and reset? Why the yesterday's latch was SR latch? That also we clearly understood. Why not AB latch? Why not XY latch? Why only SR latch? That was also discussed by us yesterday. What I want to ask you guys right now is, can you just mention me that what D latch actually stands for? In the D latch, what D actually stands for? Can you speak about this? What D actually stands for? Okay. So now I'll just tell you the connection by that particular time. Right. So just name the S input as D. Right. Take another connection from here. Invert it and put it into the R. Okay. The complement of D goes into the R input. Okay, yes. So Sai Charan says delay, Abhiram says data, Vijay says data. Actually, both the names are correct, and I will explain you the logic behind both of them. Right. The D latch, known as data latch, or it is also known as delay latch. I'll explain you the logic behind both the names, right? The logic behind both the name, right? The data latch or the delay latch, everybody, okay? Everybody. But do not forget to share the session, because within the second, third class itself, I see that it's obviously true with most of the students, because I always believe lakhs of students will fill the form, but only very few will write the GATE exam, and then very few will get the good rank. Okay, and same thing happens here also. But yes, within the very second, third class, I feel that attendance keeps going down. So do not forget to share the session, because if you maintain that regularity, then only we plan such sessions for you. Otherwise, that is no point. Small doubt. Yeah, better to complete a whole subject, Abhiram, and if you are not able, if you sometimes feel bored only by studying a single subject, you can focus 2 subjects. But each day one new subject will not be good, Abhiram. Okay, so complete 1 subject or maximum 2 subjects parallelly, and then. Okay, chalo. So now let's see the functionality, then why it is data, why it is delay. Okay, so D goes in the S input, the D bar goes in the R input. Okay, now assume that clock pulse equal to 1. Clock pulse is 0, then the circuit is closed, the door is locked. I explained that yesterday, let us not repeat this. So we'll of course assume that this is the clock pulse. This is what is the clock pulse, and the clock pulse is at 1 because it is a level triggered circuit which will only respond to level 1 of the clock. Right, now if the D input is equal to 1, then see what happens. If the D is 1, so S is directly equal to 1, but the R is equal to 0, because the complement of D goes into the R. S equal to 1, R equal to 0, everybody can remember now easily. S equal to 1, R equal to 0 means a set combination, and the next state of the device will be set. The device is now into the set state. The device is now into what? It is now into the set state. But if you take D equal to 0, so directly it goes to S, that is equal to 0, and the complement becomes 1, and the R is equal to 1. So D equal to 0, that means S is equal to 0, R equal to 1. R equal to 1 corresponds to reset combination, and hence the device will now be reset. So just try to see the pattern. If the input D is 1, the output of the device is also 1. If the input D is equal to 0, the output is also equal to 0. That means I can say that the device is just following the command of D. The device is just following the command of D. Whatever is at the D input will become the next state of the device. 1, 1, 0, pay 0. Is it clear to everyone? 1 pay 1, 0 pay 0. That is what it is. That is what it is. Or you can see like this also. Or you can try to understand like this also. What is the Q plus next state equation? S plus R bar Q. What is the next state equation we derived yesterday? For SR latch, S plus R bar Q. Right. Now if it is S plus R bar Q, now see what is the Q plus. What goes on the S? S is equal to D. Plus R bar. What is R? R means D bar. So R bar means D bar ka bar. Right. D bar ka bar, double complement will just cancel and you get D plus DQ. D is common, 1 plus Q. What is 1 plus Q in the Boolean world? 1 plus X in Boolean world is just equal to 1. So D into 1 is equal to D, and hence you have Q plus equal to D. You can either see by the equation also, directly by the binary values also. Okay. So sir, what should be the characteristic equation? The characteristic equation is finally what I have written in front of you. This is known as the characteristic equation. As I told you yesterday also, characteristic equation is also known as what? It is also known as next state equation. It is also known as transition equation. State transition equation. Right. There are also the state transition diagram, but that I will cover up in a different class. State transition diagram of individual flip-flop and also the questions based on state diagrams I will cover in a different session. Don't worry regarding to that. So characteristic equation is Q plus equal to D. What should be the characteristic table, sir? Table also I can draw easily. What is the characteristic table? The characteristic table is also known as the state transition table. Just yesterday we learned all this terminology, right? So the characteristic table or the next state table will have two inputs. One is the external input D and one is the present state, and the output is the next state. Because next state in the sequential circuits in the latches also, the next state is a function of the external input as well as the current state of the device, right? So D, now let us write down the four combination of the two bits 0 0 0 1 1 0 and 1 1 0 0 0 1 1 0 and 1 1. Okay, now Q plus is equal to the D, na? Q plus is equal to D. So if D is 0, Q plus is 0. If D is 0, Q plus is 0. If D is 1, Q plus is 1. If D is 1, Q plus is 1. That means you just copy these two. Copy the D to the Q plus. Okay. That is what is the next state, the characteristic table also. That's what. Okay. So D flip flop is just a small modification in the SR latch. The D latch is just a small modification in the SR latch. Completed. This is what is the graphic symbol we know. Wait, let me just mention, like yesterday I mentioned the graphic symbol for SR latch. This is nothing but the graphic symbol of the D latch. This is the D input, just a representation. This is CP. Now this, whenever you see this type of clock pulse, a square or a rectangular waveform, just to understand that it is level triggered device, because next from tomorrow onwards we will also discuss edge triggered devices, flip flops. The graphic symbol will be little different for edge triggered device. A small representation difference will be there, nothing much. This is Q and this is the Q bar. So let us study the clogged Jk latch now. Okay, the clogged Jk latch. Now this is again the SR latch, because every latch will be just a modification of the basic clogged SR latch we discussed yesterday. So what is the clogged Jk latch, sir? Sir, what should be the clogged Jk latch? Before I explain you clogged Jk latch, I again want to test and see how many of you know what Jk stands for. Like SR is simple, set, reset. Acha, sorry. Before we go here, why the D latch is data latch or delay latch? I just forgot to mention that. Yeah, let's discuss. Let's complete the D latch. So why the D latch is known as the data latch? One of the simple reason is it just copies the input data to the output. Whatever you apply here, right? If it is 0, it is 0. If it is 1, it will be 1. So I can say that it plays the role of data copy. Data se mera matlab hai data copy. It's a data copy latch. It will just copy the input bit to the output. I repeat, it will just copy the input bit to the output. But one more logic let us see here. I'm telling you it will just copy the input bit to the output, but one more logic if you want to discuss here. Suppose you apply the D equal to 1 here. Suppose, right? So this also becomes 1, right? And unclocked pulse is anyways 1. All the analysis by assuming clock equal to 1, because if the clock is 0, then the circuit is not transparent to the input. The door will be closed for the input, right? Okay, so now where is it? Yes. So this becomes 1, clock pulse is 1. 1 into 1 will 1 appear here. But will it appear here immediately? It will have some delay. Suppose the delay of this gate is T1. Achha, similarly, suppose the delay of this gate is T2. So after the T2 delay, this 1 is inverted and it becomes 0. Right? If this is 0, the output of AND gate also becomes 0 after some delay. Suppose that is known as T3. Right? Then the input to the NOR gate number 2 is 1, and any input to NOR gate is 1, output is 0. This is 0. This 0 comes here. What is the 0 0 output for NOR gate? It is 1. So finally output also becomes 1. That we have understand directly. If D is 1, the output is 1. But does it occur immediately? For this value 1 to appear at the output, it needs some time. It is going to travel through multiple gates, isn't it? It is going to travel through multiple gates. And there will be several delay that is involved. That means the data is copied to Q. The data is copied to the Q with a certain delay. It is not the case that you apply 1 here and you get the output immediately 1 there. Right? So this device is also used to hold the data, store the data for a particular point of time. Now, a very simple example of this you can analyze. Last class I was giving you a rough example of serial adder. I was giving you a rough example of the serial adder. Okay, what was the intent in the serial adder? That there is a full adder, there is a carry output, right, which we need to hold for a certain period of time. To hold it, what you can now use is the D latch, actually D flip flop, but flip flop we will start tomorrow, right? And what is the role of this D latch? It will copy the input to the output, but after a certain time. So that means my data is held in this device for a certain time, and then only after some time it comes here to the C in. And that's what actually we want. We want to hold the data, otherwise we can directly connect through the wire. But if we directly connect through a simple wire, the carry generated here immediately interferes with the current stage calculation. What we want, the carry generated at the output, the carry generated at one stage should be used in the next stage of addition, not immediately, na? Okay, so whenever we just want to copy the bit, but after storing it, after holding it for a certain period of time, we can use the D latch. And that is why D latch is known as a data copy latch or a delay latch. A data copy latch or a delay latch, right? So, you know, the rough design of serial ladder I gave you yesterday. You can follow the yesterday's video, also available on the same channel, right? Oh, screen is again off. You can follow the yesterday's session available on the same channel. And just a second. And yes, stay subscribed to the channel in case you haven't subscribed, so that you attend all the sessions without a miss. Okay, so I hope the reason behind the D is clear to you, that why we call it as the data copy latch or the delay latch. Okay, right. So yeah, I was asking you another question. We were coming to the Jk latch. So come on, what is Jk known as? Right. What is Jk known as? See, Abhiram, the circuit will remain to be same. So that's what I was explaining you yesterday, Abhiram. Why we call the below input as S? Why we call the below input as S, above input as R? We can call it as AB also, na? We can call it as LM also, anything. But why we call it as S and R? Okay. Yeah, why not S here, R here? The simple reason is, which of the input, Abhiram, is responsible for setting the device? So when you produce a 1 here, then only you get the output 1. So which of the input line is responsible for setting the device? It is the below line. That is why I write S in the below. That's a very simple logic, na? So we write SR accordingly to the functionality. So even if you interchange the name, functionality doesn't go away. Okay. Chalo, yeah. So I was asking you what is Jk known as. Vijay has given the very correct answer. Right, Ishan also is giving the hint. It is the discoverer name, right? It is basically the Jk latch is known as the Jack and Kilby latch. The Jk latch is known as Jack and Kilby latch. Two persons who modified the SR latch. To overcome the problem of SR latch, invalid state of the SR latch, right? So the Jk latch was first of all considered to overcome the invalid state problem of the SR latch. Actually, let me not write here because I need to modify this diagram. To overcome the invalid state problem of the SR latch. Okay. Acha. Now, how it was overcome? One more level of feedback, right? So this was basically known as the S. This was basically known as the S, and this is known as the R. Now see the modification. I take one more level of feedback connection, taking from this Q output, right? Sorry. Just a second. Yes. So now this AND gate will be used as this AND gate. Okay. What is happening? Just a second. This AND gate will now be used as a 3-input AND gate, and the third input comes here. Similarly, one more level of feedback from Q bar, and it is fed to this particular OR gate. And now we don't call these inputs as S and R. We are rather going to call these inputs as J and K. Jack Kilby inputs, J and K. Now see, I will explain you in detail, but beginning itself you see, okay, this is the clock pulse. Beginning itself you see, okay, that both the AND gates, okay, are fed with complemented inputs. One is fed with Q, one is fed with the Q bar. One is fed with the Q, one is fed with the Q bar, okay. One of them is fed with Q, one of them is fed with the Q bar. Is fed with what? Is fed with Q bar. Acha ji, okay. Now, if that is the case, it is very clear that, let me call this as again SR, because this was the SR unclogged latch. Because both the AND gates are fed with the complement inputs, so output of both the AND gates cannot be high at the same time, and that is what you want, na? You want S and R should not be high at the same time. How to avoid the invalid state? S and R should not be high at the same time, right? Now, these two AND gates are fed with complemented outputs, okay? So, if this is 1, another one will be 0, and the 0 comes to this AND gate. If the input to AND gate is 0, output is 0. Right? Or at certain point of time, this may be 0, this is 1. So this 0 travels here and output of the above AND gate is 0. So it is certain that output of any one of the AND gate will definitely be 0. That means both the AND gates, both S and R will not be high at the same time. Both S and R will not be high at the same time. Both the S and R will not be high at the same time. Okay, now how does it function? The detailed analysis. How does it function? Let's go here. Okay. Of course, the clock pulse has to be 1. Of course, the clock pulse has to be 1. Now look at the S input. How do you derive the S input? S is the product of clock pulse with J input with Q bar, but clock pulse is anyways 1, so J and Q bar. What about the R input? R input is a AND gate of, it's an ANDing of clock pulse with the K input with the Q input, so this is K into Q. Can we first write down the characteristic equation? Yes, why not? Can we first write down the characteristic equation? Okay. So we can either write down the characteristic equation or we can equal do by the value. Chalo, value se karna hai to kaise hoga? To suppose first case J and K are both 0. If J and K are both 0, dekho, just a second. First case J and K are both 0. So J equal to 0. देखो ना, J equal to 0 corresponds to S equal to 0, and if you take K equal to 0, the R will be 0, right? And if S and R are both 0, the device will remain in the same state. So this is just like SR latch. When both the inputs are 0, device will not change the state. Achha. Second combination. If J equal to 1, K equal to 0. If J equal to 1, K equal to 0, then what is going to happen? If the J is equal to 1 and K equal to 0, then what is going to happen? So guys, dekho, if the K is 0, if the J is 1, first of all, what is the value of S? S is equal to the Q bar. J is 1, na? But what is the value of K? K is 0 hai. If K is 0, what should be the value of R? R is 0. So what is the next state equation? What is the next state of the device? It is known as S plus R bar Q. Sir, what is the value of S? Q bar. Plus, what is the value of R? R is 0. So 0 complement will be 1. Right? 0 complement will be 1. So 1 into Q is Q. What is Q bar plus Q? Boolean word, guys. X plus X bar is equal to 1. X plus X bar is equal to 1. So Q plus is equal to 1. That means the device is now set. So just like S equal to 1, R equal to 0, just like S equal to 1, R equal to 0, when you apply J equal to 1, K equal to 0, device is set. ये भी similar है. Number 3 combination. Let's apply J equal to 0, K equal to 1. So sir, if the J is equal to 0, see here, if the J is 0, S also becomes 0. But if the K is equal to 1, then what is the value of R? The value of R is K into Q, that is 1 into Q. So that is equal to Q. Okay. Now, what is the value of Q plus? It is S plus R bar Q. What is the value of S? It is 0 plus R bar. R is Q. So Q bar into Q. What is Q bar into Q? Is 0. Right? 0 plus 0 is 0. So what is the Q plus is 0. What is the next state of the device? It is reset. So just like S equal to 0, R equal to 1, guys. Just like S equal to 0, R equal to 1. Whenever J equal to 0, K equal to 1, the device is reset. Again same. So it is pretty much going same, but when J equal to 1, K equal to 1. Now, On the SR latch, you cannot apply both the inputs as 1. But what about the JK latch? Can you apply both the inputs as 1? Can you apply both the inputs as 1? Just see. S will be equal to Q bar. S will be equal to Q bar. R will be equal to Q. R will be equal to Q. So S and R will not be S and R will not be high at the same time. Both are complement of each other. What is the next state equation? S plus R bar Q. So what is S? Q bar. What is R bar? R bar means Q bar. What is Q bar into Q? Q bar into Q is 0. So what is the Q plus? The Q plus is Q complement, and here you get another state which is known as a toggle or complement state. That means on the SR latch you cannot apply both the inputs high at the same time. That was SR latch. This problem was overcome by two persons, Jack and Kilby. Hence we get the JK latch. And when you apply both the J and K equal to 1, the device gets complemented. Complemented means if the current state is 0, it will become 1. If the current state is 1, it will become 0. Let us write down this once again in the form of characteristic table also. Characteristic table, also known as the next state table, transition table, state transition table, next state table, right? So let us write down this, right? There are two inputs J and K, and along with the two inputs J and K, you have the Q input. And let us see what is the next state of the device, right? Let me write down all the 8 combinations of 3 bits, 000, 001, 010, 011, then you have 100, 101, 110, 111. Okay. Okay. Now, what is Q plus? Whenever JK is 0, the device should remain in the same state. So 0 ka 0, it remains in the same state. Okay. Once again guys, see here also, whenever JK is 0, device remains in the same state. To 1, it remains to be 1. Now, whenever J0K1, the device should be reset. Whenever J0K1, the device should be reset. That is fixed. Whenever J1K0, the device should be set. J1K0, device should be that. That is what we know. Okay. Now, whenever J and K are both equal to 1, the device gets complemented. The device gets toggled. And what is the meaning of toggle? 0 will be converted to 1, 1 will be converted to 0. These combinations in the SR latch, for these combinations in the SR latch, we were writing the output as don't care. But now the output is not a don't care, it just gets complemented. 0 ka 1, 1 ka converted to the 0. Right? That is what it is. Okay. Now if I feed this in the very simple K map, to get the next state equation, transition equation, this was a transition table. Now what is the transition equation of the JK latch? So Q 0 and 1, so this is Q, this is 0 0 0 1 1 1 1 0 according to the gray code. So here J is high, and in these two boxes K will be high. Look at these two bits, right? Solving K map is your choice, however you want to solve it, however you have learned earlier. There is no restriction on that. Now this is 0 0, then 1 1, then 1 0 1 0. I only fill the ones here. Okay, and now let me complete the pairing. This is clearly a pair, and this is also a pair. We have two pairs. Where does this pair belongs to? This is Q bar, and inside J. This one lies with Q, and this is outside K, so that is K bar. So what is that next state equation? Right, so I'm not explaining you K map here in detail. K map, however you want to read K map, however is your habit, you can adopt that, because there can be multiple habits. Okay. I follow my own technique, you can follow your own technique. So Q bar is just Q plus is actually written as JQ bar plus K bar Q. This is the very important transition equation, also known as characteristic equation. This is what is the characteristic equation, next state equation, transition equation of SR latch. Okay everybody, the transition equation, next state equation. Okay guys, let's go ahead. Just go ahead and move forward. Let us go ahead and move forward. Okay, all cool. Chalo. And as always, there will be a graphic symbol representing both the inputs Jk, both the outputs Q and Q bar, and then other additional input, that is the key, clock pulse. Okay. Now, the clogged T latch. First of all, before I start describing the T latch, yes guys, can you please name what T stands for in the T latch? What T stands for in the T latch? First of all, T latch is just a small modification. It is a small modification in the Jk latch, right? This was K. Let me first redraw the Jk latch only, and a small modification. Okay, this was J. Yes guys, what is the T latch actually known as? Yes, in the T latch, the T stands for, okay. If not clear right now, let us understand the operation and then we'll easily give the name, what T stands for. Okay. Yes, Vijay, correct. So we can easily give the name. So what I will do is, only thing is, this is the Jk latch. Just short both the inputs of the Jk latch. Commonly type both the inputs of the Jk latch and call it as T. Call it as T. And the same input T goes to the J as well as it goes to the K. As well as it goes to the K. The same input T goes to the J as well as it goes to the K. Both J and K, okay? Okay. Now see the functionality, very simple, very simple. Let's do the analysis here. Of course, clock pulse should be 1 for the operation of the circuit for the latch to become transparent. Now, if T is equal to 0, right, so J is also equal to 0, K is also equal to 0 because J and K are both equal to the T input now, right? J and K equal to 0 represents what combination? Just now we learned. J and K both equal to 0 represents what combination? Same state combination. So device will remain in the same state. That means Q plus will be just equal to the Q, right? But if the T is equal to 1 guys, then J is equal to 1, also K is equal to 1. J equal to 1, K equal to 1. So if T is equal to 1, J and K are both equal to 1. So just now we learned whenever both the inputs of Jk latch are high at the same time, the device goes into complement state, toggle state. The device goes into complement state, commonly known as toggle state. And what should be the value of Q plus? The value of Q plus is known as the Q bar. The value of Q plus is known as the Q bar, right? So what is the significance of T input here? Try to understand the significance of T input. If it is 0, nothing happens to the device remains in the same state. But as soon as the T input is high, the device gets toggled. So what is the role of this input? To toggle the device. What is the role of this input? To toggle the device, and hence it is known as the toggle input, and hence this latch is known as the toggle latch. Hence this latch is known as the toggle latch, the toggle input and the toggle latch, right? Now, since we know this already, what is the characteristic table and characteristic equation? Very quickly, what is the characteristic table? Let me write this clearly once again. Characteristic table and characteristic equation, right? So characteristic table, I have the input Q, I have the input T, and then I have the output, that is the next state of the latch, that is Q plus, right? The two inputs will have 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. Now now see the value of T. Now see the value of T. Whenever T is 0, the device remains in the same state. Whenever T is 0, device remains in the same state. So whatever is the current state, I just copy it. Whenever t is equal to 1, the device will toggle. So 0 becomes 1, 1 becomes 0. 0 becomes 1, 1 becomes 0. Okay. Right. Now, if you clearly see this truth table, this is just what is the truth table of an XOR gate also. The output is high when both the input bits are different. The output is high when both the input bits are different. This is simply the truth table of XOR gate, or I can say this is the truth table which implements what? Q bar D plus QT bar. Right. Q bar D plus QT bar, or in short, Q plus is equal to Q XOR with the T, and this is the final characteristic equation. This is the final characteristic equation, next state equation, transition equation, okay, of the T latch. Of what? Of the T latch, guys. Okay. Yeah, you can go through. That's also a decent book. Okay. More preferred books are Maurice Mano or Charles Roth, as I told you in the first class, but that is also decent if you want to go Abhiram. Okay. So this is also the simple characteristic equation of the T latch. Once again, this is the graphic symbol representing a single input T and both the outputs QQ bar along with the input clock pulse, which is a level triggered device right now. Okay, and as I have told you, we have considered only level triggered devices right now, and we will be moving to the edge triggered devices also, right? So a quick reminder first of all, that this Saturday, everybody, yes, this is an online world, this is a digital world, and yes, everybody, at least most of the students, engineering students, GATE preparing students are following the online education, digital education, not only with respect to GATE preparation, even with respect to the college studies and campus recruitments, and we don't know what is going to happen the next month also. The situations are so uncertain. So because the digital world has evolved, it's even beneficial also for many students that sitting at a place you can learn many things at the same time, but the stress, the anxiety, it is developing. At the same time, we have to maintain our health also. Right. So our preparation should be on right track. Our health should also be on the right track. So I suddenly thought, yes, we will just keep you teaching, but other than teaching, yes, there are some important issues to be discussed. So join me live Saturday at 10 p.m. on the same channels. Do not forget to subscribe the channel to enjoy these sessions. If you are enjoying how to deal with the stress and anxiety in the digital age, how to deal with it. So if you are an online student, then you must watch this session. So how to deal with this stress and anxiety in the digital age. What actually the problem is, let me also focus on the problem areas, what problems usually students are facing, and what can be possible solutions. What can be possible solutions to these problems? Let us discuss this Saturday at 10 p.m. This is what is the schedule of the current series that is going on, right? So tomorrow we have the race around condition, and then we immediately move towards the master slave flip flops, edge triggered devices. Okay, that is tomorrow, same time. For digital electronics, join me live, same time at 8 p.m. daily on the same channel. Okay, so next class, that is tomorrow, Thursday, same time at 8 p.m. Race around condition and master slave flip flop, right? Edge triggering, we will discuss tomorrow. What is the difference between level triggered, edge triggered? What is the problem with level triggered? That also we'll see, and then we'll move towards edge triggered devices. Hence, we start discussing flip flops. Okay, guys, so that's it for this session. The D latch, the Jk latch and T latch is covered. Okay, yes, I'll share you the Telegram link. So actually, guys, my actual Telegram channel, is facing some problem. So we are trying to overcome that problem, but I will share you alternate Telegram link by that time, and I will share the PDF of these sessions in that Telegram channel, but the PDFs will be password protected as always. Let's also decide the password at the same time. A random password I am designing. The password of the PDF, both the PDF combined, yesterday's also and today's also, latch@12. Latch@12. Please note down, this is the password. The PDF will not be available just for free. It is available for those students who watch the session. Okay. And if you are watching it, you have the benefit of getting the PDF, latch@12. But unfortunately, my actual Telegram channel isn't responding due to some reasons. Our team is working on that. By that time, I'll share you an alternate link. No problem, I'll share you an alternate link. Yeah, I'll share you the PDFs in that particular channel for the time being. Just a second. Yeah, so you can join this particular Telegram channel, and once my original Telegram channel is recovered, I'll definitely inform you. But by the time, you can join this to get the PDF and also to get the updates about my other sessions, right? So guys, if you're enjoying, if you're learning the concepts, do not forget to like the session before we conclude it. If you're really enjoying, if you're getting the concepts, share your share your response, like the session. And if you want more such sessions, do not forget to subscribe our BYJU'S Exam Prep GATE EC PSU Preparation YouTube channel. All the best. Bye bye. Thank you. Good night. See you tomorrow at 8 p.m. Once again, all the very best.